Black holes, right. It's like they're practically designed to fascinate us.
Yeah.
These invisible things out there just eating up anything that gets too close and warping time and space. You've sent us so much on them. Are you ready to dive in?
Yeah, black holes really are where a lot of our physics knowledge just starts to fall apart, you know? And the more we learn, the weirder it gets, honestly.
Okay, so you send over this clip of Brian Cox, and it's amazing. He goes all the way back to the 1700s talking about the history of this stuff. I mean, back then, we couldn't even see these things, right?
It's wild. What they were working with back then was this idea of escape velocity. Basically, how fast does something have to be moving to escape the gravity of, well, anything, right? And some of them, they started thinking, what if you had something so massive, so dense, that not even light was fast enough to escape?
Seriously, back then. That blows my mind. But it's true. It's not just about escape velocity, is it? It's the event horizon, the point of no return.
And that's where it gets really freaky, right? I mean, imagine crossing that line. It's not like a wall or anything, but it's the point where gravity is so strong that nothing, not even light, can get back out.
So you're just gone.
Exactly. And at the heart of all of that is the singularity.
Okay, the singularity. That sounds kind of ominous.
Well, yeah, it kind of is, right? It's basically this point, infinitely dense, where all the stuff the black hole sucks up ends up. Our understanding of physics just stops working there.
So we've got these cosmic vacuum cleaners just gobbling stuff up. Then Stephen Hawking comes along and says, oh yeah, they evaporate too. Evaporate. How does that even work?
That's where quantum mechanics comes in. Hawking, he applied it to black holes, right? And he found out that they should be giving off particles, kind of like radiation, because of what's happening at the quantum level, at the edge of the black hole.
Wait, so black holes?
Yeah.
They leak?
Yeah. It's called Hawking radiation, and it's faint, but over, well, ridiculous amounts of time, that radiation makes it shrink. Eventually, it just evaporates away.
Okay, my brain is starting to hurt a little. Black holes aren't forever. They disappear.
That's the theory, yeah. But here's the thing. That evaporation, it causes a problem. We call it the black hole information paradox, and it really messes with how we think the universe works.
Okay, an information paradox. So this is less about philosophy and more about physics throwing a tantrum, right?
Pretty much. It's a puzzle, you know?
Yeah.
And not one we have all the pieces for.
Okay, so what's the puzzle?
So think about throwing something into a black hole, like, I don't know, a phone book.
Gone, right?
Exactly. Einstein's theory of relativity would say that's it. The phone book, all the information in it, the names, the numbers, everything, it's gone. Swallowed up by the singularity.
Makes sense. It's a black hole. Things go in, they don't come out.
Well, see, that's where it gets tricky. Quantum mechanics has this rule, and it's a big one. Information can't just disappear. It can change form, get all scrambled, sure, but the information about that phone book, it should still be out there in the universe somewhere.
So which is it? Gone or just hiding really, really well?
Yeah. And it's not just about a phone book, right? This screws up how we think about the whole universe. It means there might be something more, something deeper than even space and time as we understand them.
Okay, whoa, hold on. Deeper than space and time.
Some people are looking at this idea called emergent spacetime. Wild stuff.
Emergent space-time. Okay, that sounds like something out of Star Trek.
It does, doesn't it? But this is real physics, cutting-edge stuff. Imagine, right, that space and time, they're not the background. They're more like part of the action.
What? So it's not the stage the universe happens on. It's like part of the play.
Exactly. Think of a TV screen. You've got the picture, the colors, all that.
Okay, got it.
But you zoom in close enough, it's just pixels, right? Tiny dots, meaningless on their own. The picture's only there because of how those pixels are arranged, how they work together.
So space and time are like the picture.
Yeah.
What are the pixels then?
$1,000,000 question. Some people think it might be entanglement.
Like we talked about with quantum computers.
Exactly. That weird connection where two things can be far apart but still linked. Like, what if that's not just for particles, but it's what space and time are made of?
Wait, so space and time aren't empty. It's more like they're made of connections.
That's the idea. Like, the universe is this big web of connections, and what we see as space and time is just what happens on top of that because of it.
That's a lot.
It really is, and it's all theoretical, right? But that's the thing about black holes. They mess with gravity so much that we have to think about quantum mechanics too. And who knows what we'll find? It might change everything.
So if space and time are like emergent properties or whatever, what does that even mean for us? Like down here on Earth, it seems kind of, I don't know, abstract.
Oh, for sure. It's theoretical. But that's what's so cool about this kind of science. It makes you think about the universe in these huge mind-bending ways. And you never know, maybe figuring out black holes, figuring out this emergent space-time thing, maybe that leads to some pretty big discoveries. Stuff that could change things down here, too.
Okay, like what could we even do if we understood this stuff?
Well, that's where things get really out there. But think about entanglement again. If that's like the basic building block of reality, some people think we could use that. Like, imagine computers that use entanglement or communication that uses it.
Right, because of the quantum computer stuff.
Exactly. We could have computers more powerful than anything we can imagine now, or talk across the galaxy instantly.
Okay, now that future I want to live in. Seriously, though, it's kind of amazing. We started with black holes, these things just eating everything up, and now we're talking about a universe made of connections. And space and time are just, I don't even know.
And to think, it all started because people looked up and wondered about the things they couldn't even see.
It really makes you think, what else is out there just waiting for us to discover it? Something that could totally change how we see everything.
That's the best part about science. It's never over. There's always something new to find, and black holes are like the perfect example. The universe is way weirder than we think it is.
And sometimes, I guess it takes those weird things, the stuff we don't get, to show us something even more amazing.
Totally. It's like when we hit a wall and what we know, that's where the really big discoveries are hiding.
So to everyone listening, next time you're looking up at the stars, remember those black holes out there. They're not just eating things up. They're changing how we understand everything.
And who knows? Maybe one day they'll tell us even more.
I can't wait. Thanks for diving into this with me. It's been wild.